Hi there. Okay, so for today we're gonna do hands-on lab activity in linear regression, and I admit that this isn't going to be the a very fruitful one, but I think that we could handle it. So number one, is there a relationship between water salinity and water temperature? Can you predict the water temperature based on salinity? This is a very tricky one, and hence there's no music since we're pressed for time. So let me at first we have to read the data. Bottle C is this. We use the column salinity and the degrees in Celsius, and then as far as we know, as far as I tried, there's some null numbers, so we have to use this. NP is infinite df dot all 1, so it slashes out all the null numbers or infinite numbers, and then we can only get this, the three columns. Then we have to plot uh, the data, which is here, all of the data here with the grid, degrees and the salinity. So if we predict this, the more that the salinity goes to the 35 or 34th mark, the hotter the degree, hotter, or the more the yeah the more the hotter the area over here. Not much in 36. So if we put it in a linear regression line, it's gonna look like this. So with this data, we actually drop the rows with null values through 300, drop and a function axis 1, how any of the, and then we have to shuffle the data again, and then we put to train data and the valid data. It's just the same thing, but it's separate. Data 0.5, and then the what makes it difference here, it's the column here, which means it's an array, so it's just shuffling into an array. So here, see, once it go to the 12 mark, the salinity goes down when the temperature rises in degrees. So when the temperature lows, the salinity goes upwards, 34 or 35. Or we could change that, since 33, 34, 5. No, salinity is 34, 35 here. So this is the correct one. Similar at this. So salinity, the more the salinity here, and the slightly the higher the temperature. So if we put it into an array, so we're gonna know if we're gonna predict it. We have this code here. Some It's just a OLS, ordinary least squares. This is one of the formula uh, reference from the others. NT dot dot NP and return the value over here. So basically, we're just putting it into an array so that we can see the line here. This is the very difficult version, since the data is not really uh, that simple. Yeah, this is the more the more the salinity, the temperature goes down. Oops, that's supposed to be S. Salinity is S here. Temp salinity, and then temperature here. Temperature. So if we have that, there we go. There we go. So the lower the salinity, the higher the temperature. The higher the salinity, the lower the temperature. So we have to find if it can predict through linear regression. So here we separate it, the model XY, X, it's supposed to be X and Y here, the F, and see, this is why it's different, since if the coefficient has 4 values, intercept also has 2. So it's 2. So but we managed to see that there is linear regression over here. So if we are going to do that with a simpler sensor, then we have to go to number 3. I skipped number 2 since that's also very difficult, fortunately. So the number 3 is the relationship between daily minimum and maximum temperature. Can you predict the maximum temperature given the minimum temperature? So that's why we put that here. So first we read the data, max temp and min temp. The info, how much is null in float 64, and then we cut that down to 2 rows, and then we get the data frame of max temp, min temp, and the date. Only those 3 columns. Then when we plot with the date, max temp, and the minimum temperature. So this is where this is what it looks like. Then we reshape it similar to here. We reshape the values here. We reshape the values. Max temp, min temp, some min temp reshaped to 1 1, and then we separate it to a train and valid data, similar what we did here. Train data and valid data. And then from the linear import linear regression, we make it to fit X train and Y train, and it became true. Then we now go if it can predict linear model, and the linear model accuracy score is 73.1%, which means it can predict by that amount. So if we can predict that, then we can now plot. So XY test from here, cross import X train, X train, X test, Y train, Y test train, X split, XY, test size equals to 0.20, random state is 42. So we plot it out, and yes, it can predict with linear regression. Okay, so that's that. Thank you for listening.